Hi guys, so let's go ahead and look at section 2.7, solving multi-step equations, and that starts on page 80 in your textbook. So let's go ahead and get started. So for our lesson opener, we're just going to take a quick look at 1- and 2-step equations to review those. So first off, in a 1-step equation, remember we're just wanting to isolate our variable. So we are doing x minus 11, so we want to do the opposite or the inverse, which would be adding 11 to both sides. What you do to one side, you must do to the other. We end up with x equals 18. Then for a 2-step equation, we're still wanting to isolate our variable, but the first thing we have to do is get rid of our tag-along, or our annoying little brother here. We're going to subtract our 3. We were adding 3, so we're subtracting 3. We'll end up with 2y equals 2. And then when it's finally time for your best friend to go home, you do the inverse there. 2y divided by 2 and 2 divided by 2, we end up with y equals 1. In this example, we have to combine our like terms before we can solve. So remember, on these openers, you can always go ahead and try them on your own first and then check your answer with the slides so you can make sure that you're on the right track. So we have 8b and 6b give us 14b. Negative 2 and a positive 9 will be plus 7 equals 7. Then we're going to go ahead and solve our 2-step equation from here. So we'll subtract 7 from each side. We end up with 14b equals 0. Divide by 14 to get our b all by itself, and we end up with b equals 0. Another one for us here. This time we have a set of parentheses, so we have to eliminate our parentheses first by distributing. So 12 times a plus 12 times 6 would be 72. Oops, forgot my a. 12a, there we go. It's 15. Combine our like terms. 13a plus 72 equals 15. Subtract 72 from each side. We get 13a equals negative 57. And then divide by 13. We get a equals negative 57 over 13. And the last one, we have 0.4x once we distribute, plus, if you don't have a calculator handy, which I don't, go ahead over to the side. So we get 20 with 1 decimal place, so that's 2. Minus 3 equals 7. Combine our like terms. A positive 2 or a plus 2 and a minus 3 will give us a minus 1. So 0.4x minus 1 equals 7. Add 1. That's a 1, believe it or not. Add a 1 to each side. So we have 0.4x equals 8. Divide by our 0.4, which is really like saying 80, because we would have to move our decimal place. 80 divided by 4, which would be 20, and x equals 20. Alright, so far up to this point we've been working with variables on one side. Now we're going to have variables on both sides. So if you have an equation with the variables on both sides of the equal sign, you have to use the addition property of equality to move all the variables to one side of the equation. So let's take a look at example 1. Example 1 says 2x plus 5 equals x minus 2. So you'll notice if we draw little separators, we can see where our equal sign separates our two sides of our equation. I have x's on both sides. So I'm going to have to move one of them over. whenever we have positive values on both sides and one's larger than the other, it's actually easier to move the smaller one because then you're subtracting x, and now we have x, because 2x minus 1x would be x plus 5 equals negative 2. So that's how we moved it over. We had a positive x, so we're subtracting it from both sides. And we have x plus 5 equals negative 2. Just remember, what you do to one side, you must do to the other. And then we have a one-step equation here, so we can just go ahead and solve. We're going to subtract 5 from each side, because it's the inverse of our addition we were doing. And we get x equals negative 7. And then, of course, did we check our answer? Well, let's check it real quick. We would have 2 times negative 7 plus 5 equals negative 7 minus 2. 2 times negative 7 would give us negative 14 plus 5 equals negative 7 minus 2, and then we can take care of our addition and subtraction. So negative 14 plus 5 would be negative 9. And negative 7 minus 2 would be negative 9. So does negative 9 equal negative 9? Yes, we are good. Our answer checks out. Now for example 2, same sort of deal, but this time we start out with parentheses that we have to eliminate. So we're going to have to distribute on both sides, and then we'll go from there. So 3x, 3 times negative 4 will be negative 12, equals 4 times x, 4 times negative 6 will give us a negative 24. And then let's see, what side should we move these to? Well, 3 is smaller than 4, they're both positive values, so I'm going to subtract my 3x from both sides. I end up with negative 12 equals x minus 24. 4x minus 3x equals x. Then I have a two-step equation, a one-step equation, but it's backwards from usual. So we're just going to add our 24 to each side. We'll end up with 12 equals x, but remember we said we should always start with the variable first, so we'll just say x equals 12. But that's one way of doing it. Can we do it differently? So this time we moved our variable to the right. Let's do the same problem again, but this time let's move our variable to the left. So we're going to distribute just like we did before. We have 3x minus 12 equals 4x minus 24. And this time we're going to subtract 4x from each side. So now we have negative 1x, or negative x, minus 12 equals negative 24. So remember we have this minus sign here. And then we'll go ahead and solve our one-step equation. So we have negative x. We'll add 12 to both sides. So negative x equals negative 12. We never, ever, ever want to leave a negative sign in front of our variable, though. We always want to have just a plain old regular variable, because this is technically like saying a negative 1x. That means x isn't totally all by itself. So we need to either divide or multiply by negative 1 to get rid of those negative signs. So now we're left with x equals, and negative 12 divided by negative 1 will be 12. So both times we still ended up with x equals 12 as our final answer. So it doesn't matter which way you do it, whether you move your variables to the right or to the left, you will get the same answer in the end. One way just might take an extra step. Remember, we had this extra step here. We had to get rid of that negative 1. Right, so solving multi-step equations, which is what we just did, but these are the steps in case you want to write them down. So simplify both sides by removing any parentheses and combining like terms. And you want to remember, do each side separately. And I may or may not have just spelled separately wrong, but that's okay, you know what I'm talking about. Then we want to move the variable terms to the desired side of the equation, so pick either right or left. The choice is yours. Undo the addition or subtraction of the constant term, so this is just solving our multi-steps or 1 or 2 or multi-step, however many steps are left, just undo by using our reverse order of operations and our inverse operations. And then undo the multiplication or division done to that variable, that's the end of it, so add or subtract, multiply or divide. It's kind of those two go together whether you have a one-step or a two-step equation that you're solving. And then example 3. So solve 5x plus 3x minus 4. So our first step told us to eliminate parentheses, which we don't have, and then combine like terms on each side. So 5x plus 3x will give us an 8x minus 4 equals, and there's no like terms, so we're done on this side already. We just need to copy it down. Then we need to decide where am I going to move my variables. Well, since they're both positive and my larger variables are on the left, I'm going to move them to the left so that I end up with positive values. So minus x gives me 7x minus 4 equals 2. We'll add 4 to each side. So we end up with 7x equals 6. And then last step is multiply or divide. So we will divide by 7 and we get x equals 6 over 7. Remember, totally fine to leave it in fractions. You don't have to divide it out and make it a decimal. Okay, so we are moving right along here. We're up to example 4. Now this one starts out the same, but we're going to see something a little bit different when we get to the solution. So let's do this one together. If you want to pause and try each step and then compare to see if you're on the right track, that's fine. But just know that your solution is going to be funny looking. So first things first, we need to eliminate parentheses on each side and then combine our like terms. So we'll do 3 times 4 is 12x. 3 times negative 5 will give us a minus 15, and then we have our plus 2 that we need to bring down. On the other side of our equal sign, we have 2 times 6 will be 12x. 2 times positive 3 will be plus 6. Combine our like terms, we have a negative 15 and a 2, so we'll have 12x minus 13 equals 12x plus 6. Then, if we move our variables to one side or the other, this is where it gets a little tricky. We'll subtract, and what do we get? We get 0 minus 13 and 0 plus 6, which would be negative 13 is equal to 6. Well, is negative 13 equal to 6? No, this is not equal, which means there is no solution. So if you see something like this, don't be surprised. That just means that there is no solution, and that is allowable. So let's talk about no solution. An equation can have no solution if there is no value of the variable that makes the equation true. So just keep that in mind. You can have a no solution, so if you get two sides that end up not equaling, you know that there is no solution. So example 5. This is another one that's going to look different. So let's go ahead and start out. First thing we'll do is distribute and then combine our like terms. So remember, negative sign in front of a parentheses is like a negative 1. So we have negative 1 times x will give us a negative x. Negative 1 times negative 4 will give us a positive 4. And then we had our 8 out in front here we have to remember to bring down. Equals. Distribute here. We have negative 2x. And then a negative times a negative will be a positive 12 plus 12. Oh, plus x. Sorry. Plus x. When we combine our like terms, we have an 8 and a 4. So we'll have negative x plus 12 equals, then we have negative x and a positive x will give us a negative x plus 12. And this is where we're going to stop here. So you will notice that we have the same expression on both sides. We have negative x plus 12 equals negative x plus 12. That means no matter what value we put in here, it is going to end up being true. We could put a 1 or a 2 or a 10 or a 5,000 or a 15 million. It doesn't matter what we put in here. It's always going to be true. And we could go ahead and finish it out, finish solving it out just to see. If I add x to each side, I end up with 0 plus 12 equals 0 plus 12. And then if I want to technically move my 12s over, I would subtract 12 from each side, so I end up with 0 equals 0, which is true. It means that any value that I put in here, back up here at these original expressions, is going to be true. So in this case, the answer is actually all real numbers. Or we could say this. Remember when we did our number systems and all real values, it's kind of like this big bold R. So all real numbers is our solution. All right, we have a definition to look at here because let me back up here for a second. So when we have a solution of all real numbers, this is called an identity, and that's what our next definition is an identity. So an identity is an equation that is true regardless of the value of the variable. The solution to any identity is listed as the set of all real numbers, which is what we said. So we said it's the set of all real numbers. We could even do the set of all real numbers. Or we could just write all real numbers. Okay. And then last but not least is example 6. So let's take a look at it. By now, hopefully you've caught on. First thing we have to do, look at each side of our equation at these separate expressions. We will distribute, combine our like terms, and then we'll go from there to solve. So we'll distribute our 2. So we'll have 2x minus 6. Make sure you're paying attention to your positives and negatives. And then we have a plus 6 equals 3x plus 2 stay the same. And then we have our imaginary 1. So negative 1 times 2 is negative 2. Negative 1 times negative x will be positive x. Now we can combine our like terms. So we have a negative 6 and a positive 6 leaves us with 2x equals 3x and x will be 4x. And then plus 2 and minus 2 give us plus 0, or we could just say 0. So now we have 2x equals 4x. Let me rewrite it. Even though that 0 it's not hurting anything, I just want you to be able to focus on just 2x equals 4x. So this might look a little intimidating. It might look like, well, if I move my 2x over to this side, there's going to be nothing left over here. Well, don't get too excited about it. Well, what happens? What happens when you get 2x minus 2x? What are you left with? Well, you're left with 0. So this is perfectly acceptable. Sometimes you'll move over your variable and you'll have nothing left over here, and then you just call it 0. And now we'll just finish solving. So we have to get our x all by itself, so we're going to divide by 2 on each side. So we just have 0 equals x, or we should always flip it around and say x is equal to 0. And that will be our final answer. Alright, so I hope you enjoyed this lesson. I really love doing these. I think they're like a puzzle, putting all the steps together, figuring out what our answer is going to be. So go ahead and take a look at your assignment and let me know if you have any questions.